Okay, here we have notes 1.5 on complex numbers. So I have filled in some of these notes already, so I'll just read through them quickly, as this should be a review for you from last year. We're talking about imaginary numbers, which we write as I, and it's defined as I is equal to the square root of -1. Okay, so we're going to start dealing with negative radicands in the square root, and that's a good indicator that there will be some imaginary numbers to be worked with. Okay, so the imaginary unit is I, and a pure imaginary number is written in the form bi, where b is a real number and I is the imaginary part. Okay, so we're just looking at imaginary numbers, b times I. All right, so let's look at number 1. The instructions are to write each radical as a pure imaginary number. Okay, so we have the square root of -144, and as we know, we can split apart radicals as a product. So we want to pull -1 times 144, separate it there. Then we can break these two apart into two different radicals, where we have the square root of -1 times the square root of 144. And we know that the square root of -1 is I, and the square root of 144 is 12. So this is equal to 12I. As simple as that. Okay, so seems pretty simple, but this is going to be really important in some of our later problems that we're going to be working with. Okay, so I have already filled out here the powers of I. So these are probably the most important ones that you'll need to remember. And here I've shown a breakdown of how we calculate, I to the first is I squared is 1, I cubed is -1, and I to the fourth is +1. So you're going to want to have these memorized, or at least have a system of writing these down to where you can kind of get to them pretty quickly when you're simplifying radicals. Okay, so you can take a look at these individually and see how we calculated each one. There's a breakdown of it there. Okay, and we've also already put in this I to the 5th, the 6th, 7th, and 8th, which the pattern just starts over with I, -1, -I, and +1. Okay, so take some time to write those in your notes. So that you have those written down, okay? But again, I'll just encourage you to memorize the first 4, or have some method of memorizing those for when we evaluate things like I to the 11th. So let's take a look at number 4 here, I to the 11th. So we know that I to the 4th is -1 here. I to the 4th is +1 here. So we definitely want to work with I to the 4th as much as we can, especially in these smaller exponents, I to the 11th. So we're looking for the closest multiple of 4 that is less than 11. So when I say multiples of 4, I'm talking about 4, 8, 12, 16, and so on. So numbers that are divisible by 4. And the closest multiple of 4 that is less than 11 is 8. So we're going to break this down as I to the 4th, which we like to work with because we know it's 1. I to the 4th, we want to get up to the exponent of 8, so we're going to square it. I to the 4th squared is equivalent to I to the 8th. And then we have three i's left over to get up to 11, so then we'll multiply by I cubed. Okay, we know that I to the 4th is equal to 1, that's still squared, times I cubed. We know that I cubed from our chart over here is equal to -I. So we can write this as 1 squared times, -I. 1 squared, of course, is 1 times -I. That is equal to -I. Okay, so these problems where we have I raised to some power, your answers with no coefficients or anything else going on, your answers are either going to be I, +1, -Y, or +1. Let me go back here. This is negative. I squared is -1. Okay. Let's make sure. Yep, I did it right on the other side. Okay. So there's an example of that type of problem. Let's look at one that is a little bit more complicated. Let's see. Let's do number 9 here because it has kind of a little bit of everything. Okay, so something important that you need to know is that when you are dealing with exponents that are, when you're dealing with radicals that have a negative radicand, first and foremost you have to convert these to imaginary numbers. Okay, so we're going to take the square root of -9 and we're going to write it as the square root of 1 times the square root of 9, and this is going to be reduced to the square root of -1 times 9, I times 3, so 3I. Okay, let's actually move this up here so that we have some room down here to work with. Okay, so now we have in parentheses 3I, that is being cubed, and then we have 2I that's being raised to the 6th. And you know from your exponent rules that these exponents are going to apply to both the constant and the other number, which in this case is the imaginary number. Okay, so let's cube 3 really quickly, which is 27, and then we have I cubed. Okay, this is still being multiplied by this other term here. 2 to the 6th is 64, and then we have I to the 6th here. Okay, so this is a little bit easier to work with. Now we'll carry out this multiplication. 3 times 64 is 192. I'm sorry, 27. We're looking at 27 times 64. That makes more sense. 1728, so the constant here is 1728. I'm sorry, the coefficient. And then we'll add the exponents on I together, which will be I to the 9th. Okay. I to the 9th, we can either go up here, it is just beyond our, so there's a couple different ways you can simplify I to the 9th. You can look at I to the 8th is +1, and so the next in your pattern here is going to just be I. Okay, so you can look at it that way if you like to look at patterns. If you want to just get good at breaking apart these exponents, like I said before, we want to work with I to the 4th. The closest multiple of 4 to 9, that's smaller than 9, is 8. So we'll work with I to the 4th squared. That gives us 8 I's, and then we have one more. This, as we know, is equal to 1 squared times I, which is equal to I. So our final answer here, after simplifying I to the 9th, is 1728I. All right, so there is a simple and complicated problem on that first part of just simplifying pure imaginary numbers. Now we're going to take a look at what we call complex numbers. So complex numbers are written as A plus BI. Okay, A is the real number here, and BI is the imaginary number. So real part, imaginary part. Okay, so there's the 3 types of operations that we can do. There's 4 actually. Addition and subtraction, combine like terms. So it is easy if you think about these imaginary numbers sort of like a variable. Okay, so they're being multiplied by real numbers. If we have like terms, we can combine them in addition and subtraction. Okay, multiplication, distribute or FOIL, then combine like terms. And then with division, this is going to look a little bit more like when we were doing division with radicals. Okay, multiply by I, or for a monomial denominator, or the conjugate to rationalize the denominator. So excuse me, the same deal as what we were doing with radicals. Okay, so let's look at this first problem here. We have 6 minus 4i plus negative 8 plus 6i. Okay, so we're just straight across adding here. Since this is a positive term, we don't need to distribute this, so we can just kind of get rid of the parentheses here. So we have 6 minus 4i minus 8 plus 6i. And then we're combining like terms. So we have 6 and negative 8 to combine, and then we have negative 4i and positive 6i. So 6 and negative 8 gives us negative 2, and then negative 4i and positive 6i gives us 2i. And that would be our final answer there. There's no more simplifying that we can do. Okay, so that's pretty standard addition. So with the subtraction here, just make sure that you are distributing this negative to both of these terms before you get rid of the parentheses. Okay, so let's look at a multiplication one here. So this one is a straight up distribute, so distribute to each one. Kind of treat the I like a variable. I'm gonna go and I'll do this number 13 as an example because it's a little bit more complex. So we'll distribute first and then subtract, okay? So distributing the 6 to both terms, we're going to have 6 times 3 is 18 plus 12i. Okay, so I just multiplied the coefficients and left the I there just like we would with a variable. And then minus this first term, I times 5, is going to be 5i minus I times 7i. We get 7i squared, and we know that I squared is equal to negative 1. So we have 7 times negative 1, which is negative 7. So so we can say minus negative 7 there and keep it like that so you can see. Then we will make, since this is minus a negative, we know that those both will turn positive. Okay, and then we'll distribute this negative to both terms. So we have 18 plus 12i minus 5i minus 7. Okay, then we're going to combine like terms. So 18 and negative 7 is 11. 12i and negative 5i, we're going to have a positive 7i. 11 plus 7i. Okay, there's that. Sorry I keep sniffling. The smoke is super bad today and it's making my nose run. All right, so there is some addition and some distribution and subtraction. Let's take a look at, we'll do one more example under the complex numbers and then we'll talk about negative radicals. So let's do a division, a simple division, so we'll do 18, and then a more complicated division, number 21. Okay, so it told us when we have a monomial in the denominator, we're just going to multiply the top and bottom by I to get the I out of the denominator, okay? So we're going to multiply by I over I, okay? Again, we're just multiplying by 1. So in the numerator, we're going to have 6i. In the denominator, we have 7i squared, which I squared we know is equal to negative 1. So 7 times negative 1, we'll pull the negative out front. Negative 6i over 7. And that is as simplified as you can get. Okay, so like I said, this is similar to rationalizing the denominator, where if you have just a single term, you multiply by the I over I, just like in square roots. Okay, so looking at this problem, again, similar to square roots, we're going to multiply by the conjugate. Okay, so the conjugate is going to be the same binomial term with the opposite sign. Okay, so we're going to multiply by 1 plus 3i over 1 plus 3i. Okay, and let's look at what happens when we multiply these conjugates. 1 minus 3i times 1 plus 3i. Okay, so the first two, we're going to get 1 squared. The outer, we're going to get plus 3i. The inner, we're going to get negative 3. I don't know why you put this. We're going to get negative 3i, and the last two, we're going to get negative 9i squared. Okay, and simplifying this, we know that this Positive 3i and negative 3i are going to add to 0. This is equal to 1. And I squared is equal to negative 1. So we have negative 9 times negative 1, which is equal to positive 9. So this is all going to simplify to 1 plus 9, which is equal to 10. Okay. So coming back here, in this top one, we're going to have to FOIL. So we'll do the first here, 1 times negative 5, we get negative 5. The outer negative 5 times 3i is minus 15i. Inner 5i and 1 is plus 5i. And the last is going to be 5i times 3i, which is plus 15i squared. We saw just above here that the denominator is going to be 10. Let's combine like terms in the numerator. We have negative 5. Let's see. Let's look at this really quickly too. This negative 15, or this positive 15i squared is going to be 15 times negative 1, which is negative 15. Okay, so our constants in the numerator are negative 5 and negative 15, so we have negative 20. And then we'll just combine these in the center. Negative 15i plus 5i is minus 10i. And this is all over 10. We'll divide the numerator and the denominator by 10. That means each term is going to be divided by 10. So we're left with negative 2 minus I. And then the denominator will simplify to 1, which we don't need to include in the denominator. So our final answer is negative 2 minus I. And that is it for that problem. Okay, so we have a simple and a complicated division problem. Let's look at operations with negative radicals. So we'll do a simple one and then a more complicated one. All right, so the first thing that you need to remember here, that's a star, is always convert negative radicals to imaginary numbers. First. Okay, so we have this square root of negative 15 times the square root of negative 5. So we are going to say this is negative 1 times 15 times the square root of negative 1 times 5. Okay, and then splitting these apart, we'll have the square root of negative 1 times the square root of 15. And then that's the first term times the square root of negative 1 times the square root of 5. We know that the square root of negative 1 is equal to I, so those will just become the coefficients here. So we'll have I root 15 times I root 5. Okay, and then multiplying these together becomes pretty simple. We're going to multiply the coefficients together. I times I, we're going to get I squared. And then we'll multiply the radicands together. So I squared root 15 times 5 is 75. Okay, I squared is equal to negative 1, so we can just simplify this as a negative 1, root 75. Okay, and the last thing we need to do is just simplify the square root. So we're looking for factors that are perfect squares, and we have 25 and 3. So we'll make this the square root of 25 times the square root of 3. And carry this negative down here. So we have negative 5 root 3. And there is our final answer there. Okay, and then on to a more complicated problem here. Let's do number 26. We have a lot going on here. So first, always convert negative radicals to imaginary numbers first. Okay, so before we even FOIL this, we're going to rewrite this as 3 minus, and I showed you the long way to go about doing this before, but you can just, since you know that this negative is under the radical, when it comes out, it's eventually going to be an I out front. Okay, so you can just get in the habit of saying I and then whatever your positive radicand is. Okay, so 3 minus I root 3 times negative 8 plus 2I root 3. Awesome. Now let's FOIL. So our first terms, 3 times negative 8, negative 24. Our outer terms, 3 times 2I root 3. Here we're just going to take the 3 and multiply it by the coefficient. It's going to be positive 6I root 3. Our inner terms, we have 2 negative terms, so it's going to be positive 8I root 3. And then our last terms is going to be negative 2I squared. And then root 3 will also be squared here because it's root 3 times root 3. Okay, so let's simplify a couple of terms and then combine like terms. So here we know that this I squared is going to be negative 1 and that this root 3 squared is actually going to be 3. Okay, so we can rewrite this as positive 2 times 3, which will be positive 6. Okay, then we'll combine this negative 24 and this positive 6. This will equal negative, what will it be, 18, I believe. Since we have the same radicand here, we can just add these coefficients. So 6I plus 8I will be positive 14I root 3. And that, my friends, is our final answer. There's no more simplifying that can be done here. There is your complicated negative radicals problem. Okay, so it looks like we've done quite a few problems on here. Hopefully that will get you started to finish these problems. If you have questions on these problems, email me. I'm always happy to help and send extra videos. And then start on homework number 5.